Okay, so welcome back to this series of implementing a HTTP server from scratch. Last time we actually left off with fixing some of the async event loop by pulling out some data. Not pulling out some data, but rather making it a little simpler and removing the timeouts, such that we don't have to clear the connections. I actually thought about how we parse the messages, and at the moment we're not doing it very correct, to be honest. So let's go to the drawing board and actually let's actually talk about this. So at the moment we just read from the socket with a fixed size into our buffer with the size of the buffer. And we get something out and we try to parse this buffer. But the read actually has no guarantee that, or does not guarantee us to actually receive a full HTTP message. So it could be the case that a first read just gives us get HTTP 11 and character return line feed, I don't know. And maybe the first header, content length, content length 0, character return line feed, and this is not a complete HTTP message. This is not complete. Incomplete. And later on, the client writes another character return line feed indicating the end of the message. But now, we read again and see just the character return line feed, and return another 400 bad request. So this is a problem, obviously. This is kind of a problem. So what we have to do is completely rewrite our parsing, our reading interface, and the way we parse. So my idea was that we now need again a client connection, the one that we removed last time. We need a client connection. And this client connection obviously has a file descriptor, it might have an SSL object, and it also needs this back buffer that stores all of our the back buffer that stores the entire request, and this can have a max size. And if that is exceeded, we just close the connection or reset the connection. And we need some parser as well. A parser or whatever state. We have to think about this. And when a connection becomes ready for read, we read into the back buffer. We try to, when we don't have a header, so we try to find a carriage return line feed, which indicates the end of header. End of header. And after that, we try to parse the message body. Parse message body. Based on the content length. So we need the content length here. Okay. And we probably also maybe transfer coding. Transfer encoding. And if that's not possible, we have to actually wait for another read until we can parse the entire message body and send out a response. Yeah. Okay, so let's open a new tmux session. And open NeoVim. In our main.cpp. We need a client connection. That is our state for each connection. And obviously we thus now have to introduce the client connection again, as we did prior to the stream yesterday. So this clock ID business, we don't need that. Don't know why that actually exists in here. Oh yeah, clock ID 28 up. Okay. Okay, so what we want is a client connection. So struct client connection. And this client connection has a file descriptor. It might, if TLS, we have also an SSL object, end if, and we need some buffer. Some buffer that we can write to. And yeah, I don't know, maybe something else. But we will see later. So let's actually first create the pool. Let's first create the pool. So let's say pool allocator connection pool, and say init. I don't quite remember how you do that. Okay, so say void start adder is equal to allocate into the thread local memory max connections times the size of a client connection. Okay. So this is the start adder, and we try to initialize the connection pool with the start adder and the, let's say, use size or whatever. Just put it in here. So one chunk is the size of the client connection, and the entire size is max connections times size of the client connection. Okay. So I think this is the interface, use size, okay. Now, so we have this pool. So we have this pool. Now we want each time we get a new connection, we try to allocate using the connection pool. And this is a client connection star, client connection star con. We say con fd is equal to cfd. Okay, no, this is wrong. Pull this up here. And down here, con SSL is equal to SSL. And this ev dot pointer is equal to con and add this. Okay, so this is now so let's say client connection star con is equal to events I dot data dot pointer, and the sock handle is equal to con SSL or con FD. Okay. So read bytes. Let's revisit the man for ePOL control, and I want to look at ePOL hangup. ePOL on the associated file descriptor. We'll always wait for this event. Note that when reading from a channel such as a pipe or a stream socket, and you can set the peer closed its end of the channel, subsequent reads from the channel will return 0 only after all outstanding data in the channel has been consumed. Okay, so we try to read from this and close the con. Closing the connection actually has to also free from the connection pool. So let's say our close connection takes in a connection, a pool allocator star alloc and a client connection star con. If TLS, then we do this, we close con SSL con SSL con file descriptor, and in the end we also want to say free alloc and con. Okay. Okay, so in here I think, I mean, if we cannot establish this here, we cannot okay, so when we cannot allocate a new one, so if con is equal to client void star -1. And we log cannot accept new connections. Max connections exceeded. And we want to close the client file descriptor, and we want to free. No, we don't want to free. Otherwise, and break. No, go, no. I mean, we didn't really do anything. We didn't allocate anything. So in that case, we can actually break. So we set the CFD. Here we acquired one, so we have to free the connection, pull the con, and we also have to break. No, not break, continue. So in here, continue. Cannot set the file descriptor, and here the SSL object has already been acquired. So we have to close these connection pool con. We have to SSL free SSL and continue. And if we cannot establish this, I think we also do this here. Do we have to make a shutdown after? Not successful. Okay, so maybe we just do this here as well. So if all of this succeeded, we got a SSL object and can move on. Yeah, so this has to be completely reworked. This entire code here has to be reworked. We can probably pull that out. So we probably want to pull this out. I wonder which states we can actually encounter. Okay, so what we probably also want to do is make our sockets non-blocking. So when we create our socket, we make this a non-blocking socket. Sock non-block. And in our accept, we want to do accept for and put in here the sock non-block, sock non-block. Okay. Okay. One second. So we have to rework this. Make this compatible with non-blocking sockets. We could also pull this out into a new method that is called establish SSL connection. So let's pull this actually out. So in here, if TLS establish SSL connection on the client file descriptor, and say SSL stars SSL is equal to this. If not SSL, we close. No, it can close it by itself. If not SSL, we just say cannot initialize SSL connection and continue. And if this is not the case, we set SSL to SSL. Okay. And in here, we probably want to pull this out as well. So delete this and say handle connection. This is the client connection con. We probably also need the pool. So pool allocator, pool alloc to be able to call free on this. So each connection probably now needs this here, request response. Yeah, each connection will need this. So I don't know. So handle connection and say, so the client connection events i.data.pointer client connection, handle the connection. I don't know if this is even a good thing to do. Okay. Okay, so this we now have to actually make a little better. So this is now a non-blocking socket. Yeah. What is the recommended read size for Linux? I don't know. So we read. Parse HTTP request won't work anymore because it's not complete. So we need some for loop in which we read bytes. So I don't know if it's actually a good idea to pull this out, but let's say usize read bytes. This is equal to sock read with the sock handle, the request buffer, max HTTP. Editor length. Okay. So end of file would mean that okay. So I think man to read. End of file. End of file. 0 indicates end of file. So if read bytes is equal to 0, we reach the end of file. And we can close the connection. I guess. if else if red bytes is equal to -1, then we have to check the error no. Mm. So we need some read structure. That has some buffer and it has an offset. Buffered reader, I don't know. And this buffered reader has to be in here. And we read into the buffered reader. And to the reader. Oh. How do we do this? Okay, I go pee and then we will see. Okay. Ah. 1 second. Okay, reread. We have a buffered reader. And maybe this buffer is of a fixed size, max HTTP message length. This has an offset, and we can read into the reader. How can we read into the reader? Oh man, we are struggling. We are officially struggling. So reader, we try to read into the buffer. Plus reader offset. We can pull this in here. So try to read into the con buffer at the con offset. And we read max HTTP message length minus con offset. I think this is what's left. This is what's left in the buffer. We advance con offset plus equals no. Oops. Okay. So we try to read into this. Here we want to advance the offset. Red bytes. And what we are trying to do now is parse the HTTP header. Parse HTTP. No. We try to find mem find to0f. What happens when you read on an with a size of 0? I don't know. Okay, we want to find 2 0fs inside the con buffer. And if we don't find them, mem and con offset. This returns a car star. So if this pointer is not set, we have a problem. What does that actually mean if the pointer is not set? So this is not enough. This may also need a HTTP request. And a response. And does it need anything else? Some state. We need some state. And the state, so we need some way of saying, okay, in this particular client connection, we need some state. We have not read a header. How did they do it? Blah, 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 blah. So we need some way of saying a complete message is present. Headers complete. Look for end of headers. Okay. How do we do this? Okay. Let's do this. Let's do this. So if red bytes is greater than 0, else if it is equal to 0, else if it is equal to -1, there shouldn't be another case. Okay. So we have red bytes. If con offset is greater than or equal max HTTP message length then the message is to do message is too large. Let's try to do this on our own. Otherwise, we read into this. If the red bytes is greater than 0, and we have parsed headers. So let's, I don't know. Has headers. I don't know. Has headers. This is more like a state. So what? complete messages available. This is not the way we want to do this. So if not has headers, so we didn't find headers yet, and we don't find them again, then we probably just continue. If we do find them, so if this pointer is set, we want to say con, so this is con. Should we have a parser? HTTP parser that has all of this. Request. Has headers, buffer, offset. And this thing has a HTTP parser. And let's say this is the parser is equal to con parser, and use a parser, offset, parser, buffer, parser, offset, parser, offset. If we don't have headers, we check this. We check if we can find a character return line feed. If we can't find it, we try to parse the HTTP headers. Header. Okay, we try to parse this, and we want to say parser has headers is equal to true. I really hate this right now. I really, really hate this. So we now have a header. There are so many things. So many things to do right now. We have to start with something. Parse the header. It has headers. Screw it. Sock read. What happens if we already have headers? Oh man, come on. So we find this. How did they do it? Headers complete, body start. Headers end. I mean, this looks quite simple, actually. So try to find the content length, total length, Okay, at this point we have to parse the headers, which we already implemented. Now it has headers. If it has headers, I mean, it could be complete in the very first in the very first read. It could be complete. That means so if we don't find this pointer, it still doesn't have headers. So if it now has headers, so a request has a message body, which is a string. This won't solve it on its own. This won't solve it on its own. Let's go to the drawing board. Okay, so we issue a read. And we get /http 11 carriage return, line feed, content length, zero, carriage return, line feed, carriage return, line feed. We issue this read, We at the moment have no headers. We find this here. We find this. We find this here. Dupe. We pass the headers. So this might have a red val. So this might be corrupted. Then down here we have the headers now, and we say the message body parser request dot message body is equal to so what should this return? I think we are on the right track, but I don't know how we do this. Okay, message body. The pointer is equal to con buffer plus con offset. No, this is wrong. This would be the pointer plus 4. So this is a message body start. So in here, if we have, what if we have a complete message? That would mean that the parser request dot content, no, not dot content length. To get the content length. One second, I have to go and pee again. Okay. Okay. So, we made ourselves a coffee and we will do this. Come on. So, we found the headers. Here. So they were trying. When the headers were not complete, they tried to find the content length, but what if it is complete and it has no content length? So this can fail. Or is it initially 0? What if this fails? Does it just stay 0? I think this is not correct. Okay. So we have this back buffer. And we read into this a message. And let's say, okay, man, this message is complete. And we have 2 messages actually. Maybe we have 2. We might even have 3, whatever. I don't even know. So this might actually produce multiple messages. Okay, so we read into this. If this is greater than 0, if we do not have headers, we try to find this. There might have to be a for loop here as well, but I'm not so sure. Okay. We try to parse this. And we have to derive some content length, which might not be trivial. Okay, so let's say there's only content length. Let's say there's only content length, no transfer coding, no chunks. Right now, make it simple. Make it simple. Come on, make it simple. Okay. I have no idea what I'm doing. Okay, so we found this. The message body I mean, the rest has to be the message body. At least up to content length. Okay, so we don't have that at this point. And so if it has headers now, so let's maybe first look at http.cpp. So this tries to parse this entire thing. Parse field lines. What does it expect? It expects a yeah, we can actually use this. So some error code. Yeah, we can ignore that for now. So redval is equal to this. If redval is equal to corrupted, so if this corrupted header, then we just close off the connection. We are in a completely invalid state at this point, I guess. Okay. We close this, and we probably also return. -1. Let's remove this. So if this is a corrupted header, we just return -1. If not, we have now headers. So get back into http.cpp. You parse the entire thing. Let's see. This is not what I was looking for. Come on. So we can use this. But maybe we should only try to... Maybe we should only try to... Now we don't have to do this. I mean, we already... I think we should just call this... Okay, so this is probably something we don't want to do. So let's say this is not the buffer. Yeah, this is a buffer, but header size, and let's ignore the error code for now and parse HTTP header. Okay. So this is the message end pointer. Blah, 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 blah. We try to do this. We try to do this. We don't do this at the end. Okay. We don't do this. We don't do this. Parse field lines. So this parse field lines. Parse field lines. This one's an end pointer. I don't want to do this. I don't want to do this. So we get the buffer. We also get the end pointer. So buffer start, buffer end, maybe. Oh no. Header size. And this is the end pointer. This is the buffer. Buffer header size. Request line size is this. So down here, this now doesn't work anymore. So the header size includes, so what we have is not the header size, but the pointer to the end. CRLF pointer. Oh, we have to completely debug this when we're done, and that will take a while, I guess. Okay, field header, field line start pointer, message end pointer. So pass field lines. Now this has to be the end, which we already have. So maybe we call this parse thing with buffer start, buffer end. Or header start, header end. So this is header end minus header start. I don't know if we want to do this. We could also just give it oh my god. Okay. Let's just try it. Buffer end. Or okay, let's call it header start, header end. So read header start, header end minus header start. Minus header start. This is the header start. Usually you don't do this, and I don't like it. I don't like it. We have to figure out how we do this. I get headaches. Come on. Come on, come on. Come on. So this should work, blah, 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 blah. Now the problem is, how do we parse the field lines? I mean, we could just say this is the message end pointer minus the header field line start pointer. And does that work? So in here, pass header field lines. We could put the We could just put the message endpointer. Message endpointer. We say this points just to character return line feed, and then plus CRLF length. So if header field line star is equal to header field line endpointer, do this, do this, do this. I mean, this could include the so in here, parse HTTP header. Parse HTTP header. This wants the parser request. It wants the parser, so it could just take the entire parser. But okay. One second. No. Where did I put my headphones? Okay. So, parse the header. This takes HTTP. Let's do this. Let's do this. HTTP response. Maybe it was too much caffeine. I have a headache right now. So parse this. Header field line endpointer. So this takes the header size, which is not the offset, it is the pointer minus con buffer. So let's say this is already this. Such that we don't have to add it down here. You can just say this is the message end pointer. Okay, assume that. Okay, so we now have headers. This is not the con buffer, this is the parser buffer. This is the parser buffer, the parser buffer. So if we have headers, we now want to check whether we have the exactly this here, the host header, and maybe first we want to check whether we have the content length header. So has content length is equal to get parser request header map. This is I don't like this. Get the string content length content length header name, and we already did that somewhere up here. Get hash. So if not has content length if we can't infer content length, then we have a problem. So I guess we just close the thing. Or maybe this, we just return -1. And if if we have a content length, we now want to check whether whether the buffer allows us to have the entire message body. I don't like that we have it all wrapped inside multiple things here. But okay, parser, request. Oh no, so here, parser, request.messageBody.pointer is equal to the pointer plus 2 times the serial f length so if parser request.messageBody.pointer so this is the actual length. So if the content length is greater than parser buffer plus parser, no, the other way around. No, parser buffer plus parser offset minus is that right? So what are we checking here? We check whether there's enough space for whether there's enough space inside the buffer for whether the entire content is there effectively. So if content length is less than or equal to this, we have something in here. So we have the entirety of the request. But there could be more requests in here. So there can be more. So I think we have to read this entire thing. Read the entire buffer until we can't find a CRLFC, a return line feed, carriage return line feed anymore. Okay. So if this, then we set the parser request.message body dot length equal to content length. And we want to say handle request parser dot request. Probably something like this. And also if it now we have to reset the parser. That would mean parser, we would have to move all of the memory that was previously. So let's say we parsed this thing here. This was an entire request. Now this was handled, and when we want to reset the parser, we have to move all of this memory here to the start. So we want to say memcopy from into the destination, which is parser buffer, from parser buffer plus content length No. From one parser request dot message body dot pointer plus the content length. From this ongoing to what's ever left. So let's say usize remaining parser buffer plus parser offset message body dot pointer. Okay, this gets now a little remaining. No, this is parser buffer plus parser offset, so the very end minus parser. We have to change this. We have to change this. So starting from this, we copy message body dot pointer plus content length. Parser has headers is 0. No, is false. Parser offset is equal to 0. So is that correct? You could say something like car star message body start. I don't know. Okay, so this is the end, and this is the end of the message body. Okay, we copy that back to the beginning, and we set the offset to 0, and we should be fine, I guess. So here, if not pointer, we break. Out of this loop here. Ooh, which loop is that? Is it now? Okay. So if we don't have headers, we try to find the end of a header. If we have headers, if we don't have enough, so if we don't have enough, if remaining is less than content length, we actually have to wait for another read. So this would also cause us to break. Okay, so initially we have no headers. We try to find a header. If we don't find them, we have to issue a new read. This might give us now something. We try to parse the, if we find it, we try to parse the headers. Now we have headers. We try to find the content length. We see whether we have the entire message body. If we don't have it, we have to break and issue a new read. If we have it, well, guess what? We found something, we set the message body length to this. We say we want to handle the request. And we reset the parser by copying the rest of this, starting at this. With the length of the entire rest. Okay, so now we have to actually implement the handle request. Okay. And this is this thing here. So it needs so many things now. So right now I kind of feel like I want to pull this back into the handle requests method. I'm unsure. Okay. Break out of this loop. If we... So red byte 0 is... which one is this? This is read. So if red bytes is 0... If the red bytes is 0, I think we just want to close the connection. So... I mean, should we close the connection? I kind of feel like we should pull this back into the loop, but or should this be able to close it? So red bytes is 0. That means we should close the connection. So when should we close the connection? One second. Should this one close the connection? So this is the loop where, so this should be unreachable. Built-in unreachable. Yeah, I don't know. Here we have to check the error now. So if erno is equal to e would block, then this is, so if it would block, this is completely fine. We just return 0. And erno is equal to e would block, return 0, else return -1. So -1 should indicate that we should close the connection. Okay, I have no idea if this even works remotely. So here we can handle the request now. Handle the requests. This needs some things actually. Request local memory, request local memory, needs a DB, it needs a statement. Okay, it needs quite some arguments, which is not provided to this method actually. So I feel like we should pull this out. I mean, there's no way that this actually compiles. Also, also this will probably break everything. So there has to be a point where we actually have to initialize the parser, and we have to reset the parser. Come on. Oh, sorry. Okay. I would like to test this now, but this won't be able. This is not testable at this point. Con parser. At this point, we also have to initialize the parser of the. So what happens if we try to compile this with? Okay, so this won't compile. So if we have a pointer, should we pull this off? Okay, I have to pee again. This is making me willing to cry. Okay. So if this is the case, we just want to close the connection. Maximum HTTP message length. We want to close the connection, and we don't have a good interface for this right now. Also here, if we cannot find it, we try to read again. That is correct. Here, everywhere, we try to return this. Come on. 21 down, paste. Okay. Close connection, and we also want to so this takes probably the connection pool and the con, but we also want to break out of the loop. So I'm so unsure how we do this. So this would now need all the database and whatever, all of the parameters. Gigantic parameter list here now. But we have an easy mechanism of closing with returning from the function. Or we put it inside this already gigantic function. And then we have to fiddle around the loops. Oh man, this is quite unfortunate. Okay. Quite unfortunate. But I think we can make it happen. So -1 indicates close the connection. 0 indicates okay, everything is fine. And now we need to handle the requests here. So we say here if handle connection is equal to -1, close connection. Connection pool and do we want to do something else? I think we just want to close it. Okay, so handle requests. Now need HTTP request star request HTTP response star response file cache arena allocator request local memory. We need a statement as well. Oh my goodness. Do you see where this is going? Oh. Just to pull it out. This seems like a red flag to me here. These many parameters. Okay, so this also needs a writer. Buffered response writer. Probably something that's part of the connection as well. I mean, the response is quite local to this. We don't. I mean, do we want to reuse the writer? Probably, because we don't want to init it every time. Let's just put it in here. This is ridiculous. So many arguments. 1, 2, 3, 4, 5, 6, 7 arguments. Handle get requests. Request local memory. Ooh, it needs a sock handle. Where did I actually add this? Where did I add this? HTTP parser. Request. We're not getting anywhere here. We are not getting anywhere. It's getting so convoluted. It's getting so convoluted. So probably each connection what if we just flatten this out entirely? They say each connection has a car buffer. It has a usize offset. It has a HTTP request. It has an HTTP response. It has a buffered writer. So this could also be a buffered reader. So this is a gigantic structure. So handle connection. So now it's the con offset. Con buffer plus con offset. This reads into the buffer with the remaining size. We increment the offset. Here we actually didn't change that, okay. We try to find it. We parse the header. So this is also con buffer, con requests, con has headers, con request, message body dot pointer. We could also do is say this is an HTTP header and car star message body and usize content length. Request header. Then we say con message body is equal to pointer plus 2 times 0f length. This is con buffer, con offset, con message body. And we say con content length is equal to content length so there's probably some conversion missing here. Handle request oh, this just returns. No. Okay, this is con buffer from con message body plus content length. And this here. I put my glass of water. It's gone. Okay. So in HTTP, we want to say parse HTTP header, and we say this is an HTTP header. HTTP. This is now not a this is an HTTP header. A HTTP header. So this parse HTTP header, error code, don't care. This is a usize. Okay, so this now matches. I don't remember how we got the content length, so this was probably in string. Start to use 64. Start to use 64. hash. This is string, content length string. And content length is equal to start to u64 content length string. So this is if this is equal to -1, return -1. Say reference to the content length, put it in there. Okay, so now, how do we handle these requests? So at this point we have something. But this is something that is actually not... So we probably need the file cache and all of these things. We need all of these things. So I think no. So at this point we should have a nice request at this point here. So we have the request, we give it all of the arguments. Maybe we put it in the parser. I'm so unsure how we do this. I can't see through it right now, so... done. So this the handle request could just get the connection. Huh? I thought I would have added this. I thought I would have added this, so counted length. There's something wrong with this file. So when it's ready, when it is ready, con header method. Con header method, con response, con header. This is such a big change. Also, at some point we have to initialize this. So let's try to actually get this here working. File cache, request local memory, DB statement. Okay, so the header. No, it wants the connection. I don't know. So my intuition would say handle request should only get the header. It should get the parser message body and the parser content length. Okay, and then maybe it also wants the file cache. It wants a request local memory. It wants a DB and a statement. No. No, 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 no. It just gets the con. and all this if you want. So it gets all of this. And in the end, if we handled this, so let's say I32 red val is equal to 0. Again, which method is responsible for the cleanup? I don't know. Let's just make this method responsible for it. So we say red val is equal to this and go to request cleanup. Reuse this. Request cleanup resets the writer, the request local memory, the request header map. So this is con header.header map. This is con Okay, so I think we end the stream right now. This was kind of really unproductive, actually, and I don't like it. Yeah, I hope you enjoyed it. It was painful. We didn't really get anywhere. We tried to implement maybe too many changes at a time. We tried to change our broken reads, or actually we try to fix our assumptions that we can just read and it's just a valid packet, a valid HTTP message, but no, we have to first parse it out, and maybe there's even a second one in the buffer. So all of these things we have to consider, and also we wanted to make the socket non-blocking, which has several implications. That is, we have to read multiple times until we would block, and also our SSL handshake will now not work. So yeah. I guess we leave it like this. Maybe I will be back. I will come back today again, but I'm unsure. So leave a like, subscribe if you like.